Hey guys.
Hey, morning, Tony. Hi, Sungmin.
Hey Tony, hi John.
How are you?
Morning.
David, how are you?
And
How are you?
morning, guys. How's everyone?
You're a little bit faint, David.
Yeah, sorry. How about now? Any better or?
Yeah, it's better.
Okay. It was just a matter of me raising my voice. Okay.
Sound like the Pope, faint voice.
Okay. So, I think we have a quorum. Plus it's 9:03. It seems like OCP likes the 3 minutes after the hour to start meeting. So I guess we can get started. But I saw your email to Andrew. I know he was asking for links. I will reply to his email. Just I haven't gotten to it yet.
What links I sent? I thought I sent him links. What's he looking for? Pertush, do you know?
He's looking for the same stuff, I think.
Yeah, Tony shared that.
Yeah, he needs permission, right? He tried to access the links, but you need to provide him permission or whatever. I'm not sure how that works.
These should be world readable documents.
All right. Well, if he has problems, I guess just
Yeah,
you know.
I'll send the links again.
Okay.
See if that helps. Sometimes it helps when I send the links. I don't know. Yeah. Okay. So I will do that. So Tony, I'm not sure if you were able to catch up last time to the discussion we had. I was discussing with Pratyush. We were discussing with Pratyush exactly what are we missing in this design. And there's actually quite a bit missing, right? Probably the biggest hold up is the memory controller. Right. I know you sent the HBM2 models, but the controller on the other side, we're missing that.
Yeah. Have you seen the announcement we had with Alpha Wave?
Yes.
Okay, so we are actively working with those guys. Let me reach out to them to see if they have an open source memory controller. The other option is I could follow up with Avery, who actually does verification IP, and they did the verification. They have worked with Alpha Wave on a lot of their cores, so I can try to track that down. The other thing I was pleasantly surprised to find out that we do have PDKs for NAM 45 and ASAP 7.
ASAP 7, yeah. Okay. Oh, you have it. Okay.
And we have some IO buffers as well in ASAP, I think in ASAP 7. So turns out there's another, I was out in Portland a couple weeks ago and we met with a guy who's on the Caliber team, and they're building a lot of test cases. And they developed these PDKs for both ASAP 7 and NAM 45. So I was not aware of that. I think we should proceed in the physical implementation. If to get functionality, I guess we need the RTL effort as well. So assuming I can get the controller, is that something that Sigmund, you would be able to do?
Oh yeah. Actually
Okay.
today, this week I created a IO driver by myself, and yeah,
Okay.
successfully
So
implemented.
I will take the action to see if I can get a memory controller.
Mhm.
And we might be able to, we can provide some support on getting you the PDKs and the software you need, getting access to a preset to do place and route, and synthesis. So Jeff Turlip would be your probably good point of contact for that.
Mhm.
Jeff's on the call, I see here.
Yeah, Tony, for sure. I just got a hold of the ASAP 7 yesterday.
You do? Okay.
Yeah.
So have
And,
you had a chance to digest it yet, or?
there's a couple of docs,
Yep.
and I'm digesting the docs now,
Okay.
kind of as
Okay.
we speak, trying to learn
Okay.
what's there and what's not there. You
Okay.
mentioned IO buffers. Did MacRange say that there were IO buffers in there? I
Well,
don't
I'm
remember.
not sure if it was NAM 45, ASAP 7, or both, so we should check with him.
Okay.
It's just a simple buffer, but we can hack together a BOW or a UCIe, right? If we have a buffer,
Right. Okay.
but at least there'll be some physical things, so we can even do some SI analysis. We can probably hack together an IBIS model.
Tony, do you know if ASAP 7 has, if OpenRAM will compile ASAP 7 memories? Do we know? Actually, oh, shit.
Well, there are memories with it. So anyhow, let Jeff kind of sort through that.
Okay.
And we'll make a decision. If we have kind of everything available in both technologies, I think they set 7 nanometers is it's got a little more jazz appeal than 45,
Yes.
but it's really not that important. But if we can get a complete set for ASAP 7, I'd rather go that route.
Yeah. Tony, one thing that we discussed last week is whether, especially for the UC ball and the memory controller, that kind of being unknown,
Well,
and we,
you say it's going to be a little more challenging. I mean, that's a
right?
complicated beast, and I think we should just keep it simple. Just focus on the fine. Just focus on a buffer. Just fake it out to be a buffer. We're not trying to have something that is gonna be functional.
Yeah,
I don't think
yeah,
there's any way we're going to get open source
that's right.
for that. So I think we can hack that together.
Yeah. So one of the thoughts was we can just take the internal axis bus and put it on the boundary, right to the IOs, and technically that makes it a die-to-die interface. It's not UCE, it's not BOW, but it's just the bus going across the
I
IOs
have
to
no
the other
problem
side.
with Bow. I mean, Bow is OCP standard, so
Yeah, but we don't have implementation for that either, right? It's the same challenge
Yeah,
as
but
UCE.
still, we could still hack something together. I mean, we don't need the implementation for the pies. Once you
Right,
get into real implementation, then you're talking IP, and then it's not open anymore. So
yeah, I'm talking even it's about apart from the files, right? There comes the link layer and all the controller and all that stuff. Whether we should just simplify that out by just take the Axi bus and put it on the iOS.
keep it as simple as possible, right?
Yeah, yeah.
Yep.
Okay.
We're demonstrating die-to-die interfaces, SIPI, thermal, all that stuff. We're not functionality is, and the official protocols. That's something that there's no added value to the demo with that.
Yeah. Okay. Yeah, I think yeah, just ASAP 7. I found that out just now, so
Yeah.
that's good
So
to know.
okay. All right. Vikas, I see you're on the call.
Yes, Tony.
Yeah. So I did want to talk to you and Andrew, but since you're on the call, I am presenting at GOMAC in 2 weeks, and the paper is on 3DKs. So I actually have a white paper that I wrote, and then I'll be presenting. And the one slide that shows the open source translators and
Yeah,
authoring tool.
yeah.
I'd like to know if I can use the slide that I presented uh, at one of our EDA meetings to actually mention Ty and the UC guys.
I believe that is Tim's question, but I don't see any issue. Like
Well, yeah, I'm going to shoot out an email. I'm going to
yeah,
copy Andrew. Who was the other guy from?
Andrew, and then you have Puneet.
Yeah, Puneet.
Yeah,
So I think if Andrew, Puneet, and you're okay,
yeah,
we'll do that because this is a government conference,
yeah.
and I think this would be a perfect opportunity to say, hey, we're planning on using these design kits in
Correct.
for a DARPA program, and
Yeah,
that may people sitting on the fence, it may push them
yeah, yeah.
over,
No, I'm with you on that because
And-
I actually have been working on something like what the translator where 3D blocks can be useful, how OCP can be really the cockpit that Puneet was talking about because it doesn't have
okay.
a lot of details. So
Yeah.
I myself is trying to actually push that for our development kit or 3DK.
Okay.
Yeah.
Okay, so I will shoot out an email, and if you could
Yeah.
just talk to Tim, make sure he's cool with it. And
Yeah.
if
I'll
maybe we
talk to
could
him.
set up a short call, because
Yeah.
I'm just, finalizing my slides, and I'd like to use that one. So I'll put in a little plug for you guys.
Okay.
as well as, Puneet and Andrew. And, I have several meetings with a lot of the defense contractors that are going to be on the program. So, and, they're asking about this stuff, and, there's
Of
so
course.
much FUD out there, 3D blocks,
Yeah.
and this and
Yeah.
that. And, so Siemens is fully committed to this. I do have management support. We are
Yeah.
building it into our workflows. Our team is engaging that. We're using MDKs. We're using CDKs, and, we plan on using the ADKs as well.
Yeah. So they are like, and this is a really separate discussion, how we are planning to do our framework. I have made a proposal.
Okay.
We can actually have like, if you want, so do you want me to set up a meeting, or
Yeah. If you would set up a meeting, that would be good. I think that's, rather than sending a bunch of emails back and forth.
Yeah.
Let's
So
do that.
so would next Tuesday or Wednesday work for you and attendees Puneet and Andrew?
Yeah, invite Pratush as well.
Or Pratish, okay.
Yeah, let me just see. Yeah, next week.
Actually, if you can send me a couple of your slots, I will send it over. And then
Yeah, what were you saying? What days?
So I was thinking Monday, Tuesday, like whatever time suits you.
No, Mondays, forget it. Monday
Okay.
is my meeting day.
Okay, Tuesday.
I could do Tuesday morning, 8 o'clock, Wednesday, 8 o'clock. A little more flexibility on Wednesday, so I could do, well, yeah, there's a meeting that I don't know exactly when, but
See, because we are talking to Andrew and Puneet, I'll just send like whatever suits you, and then they will reply.
Okay.
Yeah.
Just see when all those guys are available.
Yes, exactly.
I'm definitely available 8 a.m. Pacific, Tuesday, Thursday.
Yep.
And I have a couple of other openings, but I still have one other, I have a 5-hour meeting that I only need to, participate for about half an hour. So I just need to find out where that half hour is, but that has the whole afternoon blocked out.
And that's fine. I will actually propose Tuesday, 8 a.m. Pacific for now.
Okay.
And let's hear back from Puneet and Andrew.
Yeah. Okay.
All right. Yeah, I'll do that.
Awesome.
All right.
Okay. So on the topic of this design, what are we deciding?
Well, we need to finalize the technology, right?
Okay.
ASAP 7 or NAM 45. Jeff will make the recommendations. We'll whatever we have the best case.
Yeah. As far as I know, NAND 45 does not come with an IO. It does not have IO buffers. It just has the standard cells.
Yeah.
But it has flexible
we can always
memory
hack something
compound.
together. I'm not as concerned, but if we have something,
Okay.
use it.
Yep.
So I think we need to decide, do we want UCIe or BOW? Right now, I guess we started with BOW, went to UCIe. We need to nail that down. So
that's the question is right.
if we're just doing dumb buffers, we could have one of each, right?
Yeah, I mean, yeah, exactly. Do we just call it a BOW or UCAE and just have really just buffers that will just a bus across?
Yeah, just have the buffers. The only thing is we'll just use a real pinout, from the spec. right? Because as far as we're concerned, from 3DIC perspective, it's a black box, and we're just having pins coming in and out,
Yeah.
and we're only concerned about the buffer, right?
Right. Yep.
Functionality is a don't care for the test chip. We're trying to demonstrate,
Workflow.
yeah, predictive analysis, and then if we have physicals, we can have more accurate analysis.
Yeah. Okay.
Um,
Yeah.
the other
I,
thing,
I'm.
David, I've been
I'm.
thinking about a little bit is, kind of in the spirit of, um, architectural planning and analysis. I know you have the ability to do power mapping from one process
Yes.
to another.
Yes.
So, what if we did a pre-layout design in one technology, and we could look at it in two different technologies? I think that would be kind of neat. What would be nice is if we could do area estimates too, and
Okay.
um, that's a little bit trickier, but I know that OCP has a cost estimator. Do you know about that? There's another
Yes.
working group that has that. Has anybody looked at that?
Yes.
And I think it's just a spreadsheet, right?
Yes.
So why not, since we're promoting OCB standards, why don't we have that as our technology scaler, right?
Okay.
So we could, look at, we could kind of walk through the whole thing. We start out, with high level, system level, plan, and then we can, pick two different technologies and look at the trade-offs of the two, hack up a cost model, an area model, and power model for each of the technologies, and just go back and forth between NAM 45 and ASAP 7. So I think that would kind of, just with a simple spreadsheet, we could do something to do some of that, and that's something we could do in parallel, right? So
Yeah.
whatever technology we choose, we for the implementation, we continue down that path, but we could also take our original, uh, you know, architectural spec that we captured at a high level and map, and we can say, oh, this is the technology we choose to implement, and maybe even someday we can implement in both technologies to see how well those mappings really work.
Okay. Let me think a little bit about that. I think that's a very interesting thought.
Yeah.
Um,
And again, this is a living, breathing thing. I don't want to detract from what we're doing. Let's continue to break it through. But the thought is we can just keep building on this, and
yes. Yes. Yes.
adding and adding it. And each OCP conference, we can show some new functionality or new formats or new capabilities.
Yeah. I see. Yeah. Let me think about that a little bit. Exactly what this would entail. My biggest red flag right now is the scaling from NAN 45 to ASAP 7. That's a huge step, right? Typically, it's not like that. Typically,
Huge
it's
step from what perspective?
from technology node point of view, right? Going from 45 rules down to 7 rules. It's a huge step. So I need to think a little bit what does that mean, right? Power is going to be different. Area is going to be so different that would the result look weird,
Well,
right?
you know,
Because
again,
probably,
the way we thought about this earlier was this is a scalable, uh, uh, you know, a really it's a scalable processor, right? So we can
yeah.
change the number of cores, right? So in terms of scaling, you know, maybe we could do a 2x2 in 7, and maybe that's a 4x4 in 45, and you know which one, you know, let's say that's comparable performance, and look at the cost, right? You know,
Yeah.
it's not obvious which one is lower cost.
Yeah.
Or look
It-
at the area, you know, have the same area, so you have a lot more cores, and then see how much more compute you get, or
yeah.
analyze the cost and look at, you know, make those trade-offs. So,
Yeah.
and if we could do
Yeah.
that at a very high level without having to actually have to crank through a lot of stuff, that's very powerful.
Yeah.
You only need
I,
two
I, I,
technologies, right? And we could do a lot of trade-offs in just
yeah.
those two technologies.
Yeah. I do get your point. I agree with the overall idea. I'm just worried if there's any hidden rocks in all of this that would make it look weird, right? For example, if we decide, right, if in 45 we can do 4 chiplets, each is 10x10, and we end up in ASAP 7 with one chiplet that is 7x7, this is going to look really weird, right? I
Yeah,
mean, cost and
yeah.
area wise and things like that, right? I just,
Well, yeah,
I,
yeah.
I
It's an
probably need to,
extreme. It's an extreme.
right?
Yeah, you're right. I mean, I see your point. Yeah. So it may
Right.
be too dramatic, but again, it's an extreme corner case, right? You know,
Yeah.
going from 45 to 0.7 is a big jump.
Yeah. Yeah, I do get your point, and what I'm trying to say is, how do we demonstrate that elegantly without making it look weird or totally fake, right?
Mhm.
That's my only thinking.
Yeah. Yeah. Maybe it's one core and 0.7 and, you know, 60 cores, you know, maybe
Right?
make it the same area, right?
Yeah. So, but normal trade-offs are not exactly like that, right?
True. True.
There needs to be. I need to think it in reverse. Right, the normal trade-off that we want to do that is getting done every day, how do we make it kind of like that with the data we have,
Yeah. I mean,
right?
140, I mean, you know, the Skywave, what is it, 130 versus
Once,
45?
yes.
That's a more realistic technology swap. But,
Yeah, there was a 15 nanometer library as well, by the way,
oh,
that might be used for that, but I need to go and dig it up and see if
7 and
what's
15
available,
would be very interesting.
right? So let me I need to see where that is. It's NAND 15.
Okay. And Jeff, maybe you could check to see if that's something we have.
I haven't heard
Yeah.
of it, but I'll look into it.
I
NAND
mean,
gate
I
15.
remember, you know, I talked to about 10 different universities, and that came up
Yeah.
in one of my discussions. But the problem was nobody had a complete set. Well, these guys have memories, and these guys have standard cells, and these guys have,
Yeah.
it was all over the map. And you know,
Yeah, exactly. Yeah, NAND 15 was really never took off. And the reason for that is the uh, assumed spice models were kind of unrealistic.
mhm.
They were still assuming planar transistors, and we're ending up with I think great performance and a lot of leakage. That real process wasn't like that because the real manufacturing guys did figure out a few things and they went to FinFET. And that's why NAND 15 never really took hold, I think.
Yeah, Global Foundry has an open source library,
Wasn't it 65 or something?
something like that. Yeah.
Yeah.
So, I mean, we could go backwards and do 65 versus 45. Yeah.
Yeah.
I like
Yeah,
this
let me
15 better.
yeah, right. Yeah, as I said, there's a few things that need to be considered around this, right? To make the data needs to make the same points that we want to make.
Right. Right.
So I need to think a little bit about that.
Okay.
I think though, on the original the discussion, getting open road working on our designs would be very beneficial because all these trade-offs can be made by everybody, right? Using the same tool set. I think it's great that you guys have the Prism PDK and that place and route can be done. But then, right, for example, for NAND 15, we don't have that, so trade-offs are going to look weird. If we can get open road going on the open source tools, going on one technology, I think that's going to be perfect.
Okay.
All right, and then we can keep spinning and see what the real data looks like.
That's fine.
Yeah. Yeah, the question is how do we get to that point where we have that piece going?
So
I haven't used open road.
Oh, it's we lost Pertush. Oh no, you're still there. Pertush is who is that? Andrew that is responsible for open roads.
Yeah, Andrew, along with the Precision Innovation folks, they have worked on it. So Tom Spiro is the guy.
Do you think we can get their help to set up this design, the one that we have, to set up a flow that we can all use and get going with open road?
We
Probably.
definitely reach out to, we can get.
Pertush, you want to take that as an action?
I'll write to Andrew and Tom Spiro. Okay.
Yeah. Yeah, also CC me and see if you don't mind, if that's okay.
Yeah. Okay. Yeah, no, I'll start a thread on this one. Yeah.
Because I think that's going to be a very interesting exercise.
Yeah. Let me just. Excuse me. I'm sorry.
Bless you.
Bless you.
Actually, I have a
Bless you.
sorry.
Whatever it was.
I have a progress in designing with NAND 45.
Oh, cool.
Yeah, can I share my screen? Yeah.
Yes, please.
Sure.
So, yeah, can you see my screen?
Okay, here you go. Yep, we see it.
Yes. Yeah. So I redesigned the chiplet with the footprint 2.5 millimeter by 2.5, and I was able to design successfully.
Okay, great.
And and please note that these design results are done with the commercial tools, Synopsys and Cadence. So we have to migrate all these design flow to open road, I guess.
Okay, yeah, but okay, so now now we have a good size. So, assuming the idea in this is that this CPU that you have, that's not going to be the chiplet. The idea is to take a few of these CPU cores, put them together, and that will become the chiplet.
But yes, but we can chipletize this CPU. Actually, I've done in the later slides. So, so with the IO driver, I first designed the IO driver, and the RTL. There is open source IO driver, AIB driver. So with these RTL, I designed two versions of IO drivers, and one for single bit and one for 24 bits. But this week I used this simpler version.
Mm-hmm.
And with this IO driver, I modified the netlist. So as you said, this one tile is to, if this one tile is combined, the multiple tiles are combined together, that's gonna be a chiplet. But we can make this one tile as a one chiplet by modifying the netlist and some signal IOs. So I combined the split signal IOs in the original netlist, and the total IO was 453, and for these signal IOs, I connected to IO driver I made.
Okay.
And I also create the microbomb tech file, left file, for the implementation. So I'm trying to run the PNR with microbombs and IO driver, and create this one tile into a chiplet. So, but the signals are randomly assigned for now.
Yeah.
And I'm thinking adding some power bumps or moving the signals to the boundary.
Yeah.
So yeah.
I think this is very good. I think this is great progress. Once you have chipletized this one single CPU core, I think it would be great to make it into basically, instead of one CPU core, you can still keep the IO boundary, right? And have that one, the AIB bus that's going out. Just instead of one CPU core, there's going to be 10 of them, maybe, right? To make it a little bit bigger chiplet with a few CPU cores in it, right? And then it's still going to be single AIB bus going out, right?
Yeah.
Oh, yeah. Yeah. This is good. This is great. Yeah.
Yeah.
So you basically, you kind of already have with this. Actually, I have a question on the AIB driver. Can you give me more details about that? When you say driver, what is it? Is it just the RTL that?
So on the GitHub, they only provided the RTL. So I synthesized and run the PNR with Nengate 45.
Okay, so this is, let me understand. So this is, when you say driver, so this is a single bit AIB bus RTL, is it?
Yes. I think
Okay.
it's more close to IO buffer. Inside the RTL, there was only D flip-flop and inverter. So
an AIB is, I mean, that's really kind of UCIe Express is based on AIB, and there's claims that it's backwards compatible. So if we had an AIB buffer, we could use that for a UCIe Express if you have the RTL. Is the RTL just instantiating buffers, or does it have some protocol logic in it?
In IO driver for 24 bits, I have that kind of precursor kits and
Okay.
yeah, functions. So yeah, if needed, I will change to use that 24 bit IO driver instead of for a single bit. Yeah.
Cool. Yeah. So that would give us kind of a we could just call it we could lay it out as a UCIe and use the AIB, and that's close enough to call it UCIe, even though it's AIB. It doesn't have all the bells and whistles, but again, there is in theory backwards compatibility support from UCIe to AIB. So we just call this an AIB configuration of a UCIe.
Yeah. Do you know why is it 24 bits?
I have no idea for that. I just follow the RTL and
Okay.
yeah.
Is the RTL parameterized for the number of bits, where you can just change the number of bits?
I would think, or that shouldn't be that hard to do.
Oh yeah, I think. Oh yeah, I'm now looking into the. Oh, let me share my screen. Yeah, so in the RTL, we can change the data with, I guess.
Okay.
Yeah.
Yeah, we should. Yeah, good. We should make it 64-bit then, which is
64,
what
yeah.
UCIe kind of looks like, and that's it.
Okay, sounds good. Yeah.
Okay. So then the die-to-die portion looks to be kind of done then, right? We use this RTL with 32 or 64 bits. We can decide now which one, if there's a strong preference, one versus the other, and use this as the die-to-die interface.
Yeah, sounds good. Yeah.
Tony, what do you prefer, 64 or 32?
Say again.
What do you prefer as the bus width, 32 or 64?
I think 32 is fine.
Okay, then 32 it is.
Okay.
B, so the die-to-die. So then the plan is use this as the so-called die-to-die interface, and then just increase the CPU core count inside the chiplet to a little bit more, make it a little bit more interesting. And then the only thing that is left is how do we talk on the memory side?
Yeah.
Yeah, I'll look into that.
Okay.
Yeah.
And then see if we can port this work to open road. And I will think about the technology scaling and comparison and in the context of estimating cost.
Okay, and you're going to look at the OCP cost model?
Yeah, I know the cost model. I've seen it before. I've looked at the spreadsheet.
Can you send that out or send a link in the chat?
Okay. I don't know. I have to dig it up.
Okay.
I'm serving responses from memory right now.
Okay. No, just send it out in the meeting notes or something.
Yeah. Yeah, the biggest challenge there was really the packaging piece was not very well defined. Right, there was a lot of stuff in the cost model about trying to figure out technology and die sizes and costs, right? Die cost, right? What technology, what die size, and so on. And the packaging piece was left a little bit. There's one or two cost numbers that you can input. Right, if you have to compare this interposer cost versus the other interposer cost versus the third interposer cost, and then assembly cost, yield loss in that, that piece, as far as my memory serves, wasn't well defined. But I think, yeah, let me dig up the link to that. It's somewhere on the OCP pages somewhere. I'll dig up the link and we can see what's in it.
Yeah. Okay.
Okay. I think this was a good meeting. We made a good plan,
Yep.
and I'll see if I can take a look at the Nengate 15 libraries. What were the issues in that?
Right.
And if right, I just got the ASAP 7. I'll take a look at those libraries as well and see how things look.
Very good.
All right. Anything else for today?
No, I agree. Good meeting.
Yeah. All right. Okay then. We'll meet next week then. Thanks everyone.
Thanks, everyone.
Thank
Thank you.
you.
Thanks. Hey.
Rose, you want anything from